on lesson 3. Because I know you had to do that one mostly on your own. And I do apologize, but I didn't want to give anybody the flu. And it turns out that it wasn't a sinus infection, it was the flu. I was in bed all the last part of last week. So part of your assignment was to complete these practice problems. Does anybody have any questions on these? The first one says, Will is 22% taller than Wanda, so Will's height is blank percent of Wanda's height. Any of those you have questions about? Has everybody completed those? Did you have to leave any blank? Okay. Just so that you know you're doing it right then, let's go down and let me give you the answers. Will is 22% taller than, so plus Wanda. So Will's height is 122% of Wanda's height. Now, if there's one that I say that is different from what you got, say out. So we can figure out why my answer is different from yours. Second one says the area of Norway is 20% more than the area of Colorado. So Norway's area is 124% of Colorado's area. The population of Virginia is 18% less than the population of Georgia. So Virginia's population is 82% of. You would have to subtract that one from 100 because it's less than. The net worth of Zelda is 6.4% less than the net worth of Alicia. So Zelda's net worth is 93.6% of Alicia's net worth. The wholesale price of a television is 40% less than the retail price. Therefore, the wholesale price is 60% times the retail price. And it would have been okay in that case to put 0.60, because if you're going to multiply times, you have to actually go ahead and change the decimal anyway. Stores having a 25% off sale. Therefore, yes?
Number 6, we've got a different thing. It says the store is having a 50% off sale.
Okay, I need to check that. So let me first of all mark it and then answer the question with it being. I didn't realize that. I may have pulled from a different one from what y'all had. So this is a 50% off sale?
Yeah. Actually, it's worded entirely different. It says the store is having a 50% off sale, therefore the original price of an item is blank times the sales price.
Ah. I didn't realize we had two different sets of that. Okay, since it is the original price, that's a before. So it's going to be, and it's not going to say, it shouldn't say times, does it?
Yes. It says blank times the sales price.
Okay, then it should be 150% or 1.50. I'm not sure it should say times.
I was confused on that one, that's why I had a question mark beside of it.
Okay, and that, you should have asked about that one. Please always ask if you're stuck on one.
Okay.
Yeah, we're gonna give you credit for that one no matter, and I will make sure that I alter the handout. What this should have said in order to make all of that work, you couldn't even use percent actually, you'd have to say 1.50 divided into. Because that would have given you the right answer. Which is actually, I think, the same as multiplying it, but we'll leave it at that. So I'll give you credit for number 6 regardless, and I'll make sure the wording on the quiz questions and test questions isn't that confusing. Okay, number 7. And if you're stuck on one even before the homework's due, you can ask questions. Just post your question and show me. Don't be confused, just ask. Retail of a cost of a TV is 30% more than the wholesale cost. Therefore, the retail cost is 130% or 1.30 times the wholesale. Retail is higher than wholesale, so you're going to multiply it by a percentage that's larger than 100%. Yes.
When we do tests in homework, does be the first to put that O on there? And I left it off.
No, I'm just saying that either answer is acceptable. I'm going to assume that you know how to convert from a percent to a decimal to actually do the problem. Okay, number 8. If Kenny earns 142% of Benny's salary, how much more does Kenny earn than Benny in terms of a percentage? Kenny earns 42% more than Benny. Okay? This one's actually asking about the percentage. So Kenny earns all of Benny's salary plus another 42% of Benny's salary. Bob makes 32% more than Clay. So Bob's salary is 132% of Clay's salary. Number 10 says, during the sale, the price of a sofa was discounted by 30%, which of the following is true? The sale price of the sofa is 70% of the original price. Because it's going to be less. When you multiply by 0.70, it's going to be less. And it doesn't say it's 70% less than, it's actually 30% less than, so that, you can't choose that one. Regular price is 30%, 130% of the sale? No, that would make it more than the sale price. The regular price is supposed to be higher, but the sales price isn't going to be found by multiplying 130% times the sale price. And then the sale price of the sofa is 30% of the regular price. No, it says it's discounted by 30%. So 100% of the price minus 30% of the price gives you the 70% of the regular price. Retail cost of a computer is 27% more than the wholesale cost. Which of the following is true? Now, retail is always more than wholesale. So retail is before, wholesale is after. And if the retail is 27% more, then that means in order to find the wholesale, I'm going to do 1 minus 27%. So it would be, the retail would be 70%, 73% of the wholesale, but they've got the wording backwards in Part A. Retail and wholesale are in the right order here, but 127% is not the right percentage. And in D, the retail and the wholesale are in the right order, but there again, it's not 127% off. So part C, the retail cost of the computer is 27% of the wholesale price. Wait, no, I think the answer on my key was wrong on that, because looking at that, retail it's D, it's not C. Because it is 127% of the wholesale price. It is 127%. Sorry. Now, if there's any you disagree with, don't hesitate to say. You got something different or don't understand why it is what it is, then I'll be glad to go over it. Because I marked these off of the notes that I had, but hadn't really necessarily gone over them lately to make sure that that they were correct. Okay, the value of Ann's house is 700% more than when she bought it. When she bought it was the value, or the original, that's the before. This is her after. And her after is 700% more than. So which of the following is true? Well, when she originally bought it, that was 100% of the price. Since then, it has increased 700%. So the total value of her house today is 8 times more than when she bought it. You can't choose C because C says the value of Ann's house is 800% more than, and that's a direct contradiction of that. So that's why you can't say part C. And the value of Ann's house today is 700% of, no, not of, more than. And then part D, the value is 7 times. Well, no, it's actually 8 times because you have its original price plus 7 more times its original price for the 700%. So that's a total of 800% or 8. This would be correct if it said 8 times, but it says 7 times. Okay? John is 9 times as heavy as his dog. Which is the following is true? Okay, he is 9 times as heavy. That's all of his weight plus 8 times the weight of his dog. Or plus 8. Let me back up and try to say no. All of his dog's weight plus 8 times the weight of his dog. So he weighs only 800% more than. He doesn't weigh less, the dog doesn't weigh 800% less than him. That's not what the problem says. One does not follow from the other. And his weight is 800% of his dog's weight. Well, actually, no, it's 900%. Because it's his dog's weight plus 8 times the dog's weight. And then he weighs 900% more than his dog. No. He actually weighs 800% more than his dog. Because that's what it actually says. He's 9 times as heavy, so it's the dog's weight plus 8 times the dog's weight. Questions on those? Those can be confusing. Anybody have a different answer? When I look over your homework, if I see that you missed any, I'll give you some pointers on how to figure things out. Then you had some 2-step percentage problems, and this is where you wind up taking your notes on your own. And I didn't get the key to that one. but I am gonna tell you how you would have worked it. Purchase a bicycle with a retail before tax price of $760. And pre means before, so that gives you a big clue on what's before and what's after. The local sales tax rate is 7.6%. What's the final cost? Is the final cost more than, does that make it after?
Or not something different.
Does yours say something different?
Oh, no, okay, I was looking at I was looking at the examples for the rest of the.
Oh, okay.
The, notes.
Okay, yeah, because the examples are worked out in the video. I want to make sure that you got these, because those are not in the video. Okay, so we have a before tax price. We want the final cost. Since the final is more than the before cost, then it's going to be adding. And since it is a 7.6% sales tax rate, what we're gonna add is 100% plus 7.6%, which is 107.6%, or 1.07. And we're going to multiply because it says more. So what we're gonna do is we're gonna take our retail price, our before price, and multiply times 1.07. And the rest is arithmetic, so as long as you did that process, you should have the right answer. Between 2000 and 2010, the percentage of fatal automobile accidents due to speeding decreased by 34% to 16%. So the 16% is an after. What percentage of fatal automobile accidents were due to speeding in 2000? 2000 would be before. So in this case, it decreased. We're looking for a negative answer. And if we're looking for a negative answer, it decreased by 34%, and it wound up at 16%. So after was smaller, before was the larger, and before minus after gave us negative 16%. So 0.16 divided by the before. I'm sorry, divided by the after. And I'm sorry, I wrote the wrong one here. This is 34%, not 16. It decreased by 34%, so it's going to be 0.16, which is your percentage point here for after. So it's going to be 0.34 divided by 0.16, and the 0.34 is negative, so it's going to give you a negative answer. Okay? That should give you the rate for before. Let's check and make sure our answer makes sense. That's not making sense.
How about that it was 66%, I took 100%
Okay,
yeah, you're doing it better. Let's go back to the logic we use here. It decreased by 34%, 100% minus 34% is 63%. And it's 63% of the 60, oh, 60, I'm sorry, 66. But it's 60%, 66% of which value? 16%, right?
It should be,
Yeah, it should be divide. I hit the wrong button. I'm sorry, folks. So it was,
it's the other way around, it's .16.
Yeah.
by 66.
I think I need to go get some more caffeine. What do y'all think?
I can't function without
I've only had one cup, and it's the first cup I've had since last Tuesday, so. 24%, 24.2. So yeah, 16% is your after divided by your percentage change. Get this out of the way. Okay, the number of housing foreclosures in 2008 was 3.9 million, which is up 81% over 2007. 2007 is before. How many foreclosures were there in 2007? Okay, if this is 81% more than 2007, what do we need to do here? So what does more tell you? They increased, which is plus, and it's up 81%. Right. Which is 1.81. And what do I do with the 1.81? Into 3.98 million. Let's see if this answer makes sense. So is 2 point, okay. So is 2 point, let's see, 2.20 would be the rounded number. Does that make sense for 2007? Yes. It makes sense for 2007, because if you take that 2.20 million, sorry, if you subtract the 2.20 million, 3.98 from the 3.98 million, that's a difference of 1.78 million. And that does make it up. And you can verify for yourself that 3.98 is 1.78 or 178% of, I'm sorry, no, it is 81% up. So if you take the 1.8 and divide it into the 3.98, you will get 2.198, and the answer does make sense because that's a difference of 1.78 million. And 1.78 is well over half of 2.28. So it did increase by way more than 50%. Okay, Brandex Copier advertises that its copiers run 24% longer between service calls and the competitor. If Brandex Copiers runs 56,900 copies between services, how many copies would the competitor run? Okay, they run more. More tells us to add. Add tells us it's 124%, which is 1.24. Now, if this is 1.24 times the competitors, then we're going to take the 56,900 and divide it by 1.24, because if you were to multiply, you get a larger number, you need to get a smaller number. So the competitor ran 45,887 copies between service calls. Any questions on that one? Okay, number 5, between 2000 and 2010, the percentage of U.S. households with cordless phones increased by 13.7%, so it's up 13.7% to 91%. What percent had cordless phones in 2000? This is 2010. 2010 is after. We're adding, so that means we're going to go to 113.7%, which is 1.137, and because this is a positive difference, that tells us our reference value is which number? It's 91%, right? So we're going to take our 91%, and in 2000 it was less, so that tells us we're not going to multiply. And don't change that to a decimal because we're talking about percentage points. So in 2000, .0% or 80% of U.S. households had cordless phones. Less than, a percentage that is less than what it is in 2010. In a local election, 21,700 people voted. This was an increase of 6% over the last election. Since this is positive, after minus before would give us our absolute increase. And then how many, we need to do this in percentage points. So the after number is 21,700. Increase of 6% means it's 106%, which is 1.06. And that tells us that in the last election, 20,470. Well, 72. $20,472 people voted in the last election, which is less than the people that voted in the most recent one. So always go back at the end and say, okay, now, should my answer have been more or should it have been less? And make sure that your answer went in the right direction. In a local election, 41,800 people voted. This was a decrease of 9%, minus 9%. So that's 100 minus 9% equals 91%, which is 0.91. So 41,800 people voted, and this is down, so the original number was supposed to be more. So 91% times how many people voted in the last election? Gives us the 41,800. So we're still going to divide because there were more people voting in the last election than there were in this election. If we multiplied, we'd get a number less, so we need a number more. I left out. Yeah, I left out 41. Scratch that. Left out the 1. So that means in the last election, there were 45,934 people. And 45,934 is a larger amount, so we did see a decrease from last election to this election. So the answer needs to make sense. That's the main thing I want you to be sure, is your final answer makes sense in context of what you have. Now, does anybody have any questions over these? Because if I made a mistake, I would like to, yes.
I got something different. I don't know what I did wrong. It seems like I feel like I did the same thing you did. Oh, no, I didn't. I had the numbers.
Yeah, because it was decreased, and your reference percentage is gonna be 91%.
Yeah.
Okay? So this is 91% of whatever this was. But since we don't know what this is, rather than multiply, we're gonna have to divide. Look back at the, try to find the right page. Okay, let's look back at the notes for a second. If you're confused, this is where you really might want to even go back and watch the video again. These are always going to be two-step problems. It says these indicate a percentage of increase or decrease. That's the key words, increase or decrease. If it went up, you add. If it's a decrease, if it went down, then you subtract the percentage on every one of these. So if you look at the problems that we've got down here in our examples, without even going to the second step, your purchase with a labeled pre-tax price is $17, the sales tax is 5%. What is your final cost? Sales tax is added, so that's an increase. Therefore, we add, and we use 105%. And the next one, it says your receipt shows you paid $19.26 for a Blu-ray disc, tax included. The local sales tax rate is 7%. What is the pre-tax? Okay, here again, tax is added. So we're going to add in the problem. I'm sorry, wrong color. $80 item is on sale for 40% off. That's a decrease. So if it's a decrease, that means we're going to subtract. 100% minus 40% gives us 60%. And in the last problem, the rate of smoking was up. That's an increase. So again, we add. And then in step 2, remember, all you're doing for step 1 is determining did it go up or did it go down. If it went up, add that percentage. If it went down, subtract that percentage. And then in step 2, going back up here to your model that you go by, the other value given in the problem is the amount that is increased or decreased from before, or the amount that is increased or decreased to, which is after. If you have the after, then you divide. But if you have before, you multiply. So in our first example, step 1 was to get the correct percentage point, which is 105% converted to 1.05. Step 2 says, is $17 before or after the tax is added? Well, it's before. And before tells you you multiply. So you multiply to get your answer. In the next example, though, it says, again, we have sales taxes added, which is 1.07, but then which price do we have? We have an after price. The price is after tax. So we divide. And then an $80 item is on sale for 40% off. That means it went down. So we use the negative. Says, what's the sale price? Well, you have to know the original price to get the sale price, so original is before, sale is after, okay? So it's after removing the discount. And when you have after, you divide. This is the before. We should have okay, sorry. Yeah. We have after. So we multiply. We were given the after, sorry. And then the last one, it says the rate of smoking went up, and after it was 10.4%. And we want to know what was it before. And since we have the after, we want to divide. Now, without going too much further, let's go back and look at these again. After we've worked them according to the method, the end result says that in the first problem, what is your final cost including tax? Is that going to be more than 17 or less than 17? More. Is your answer more than 17? Yes. Okay, your receipt shows you paid $19.26, tax included. After or before? That's the after. So the local sales tax, or what is the pre-tax? That's the before. Is the before going to be higher or lower? It's going to be lower. So that means $18 is less than $19.26, so that answer makes sense. $80 item is on sale for 40% off. What's the sale price? Is the sale price going to be more than 80 or less than 80? Needs to be less than. So you multiply that shouldn't be the sale price. That one's bothering me. Because the price is on sale, it should have gone. Okay, no, never mind, sorry. My bad. It's $80 before and $48 after. Somehow my brain did not follow that, but that is the right way to do it. Okay, same thing here. Rate went up. So is our final percentage going to be higher or lower? Well, the previous smoking rate is going to be lower if it went up. So our answer is 7.2%. Is that lower than 10.4%? The answer is yes. So ask yourself the question. Don't think that there's just a magic formula for these, even though there is a relatively good process. In the end, if you get confused, make sure your answer makes sense. Should it be larger or should it be small? Okay? Use the wording in the problem to figure that out. Okay, we're going to talk about something new. I'm gonna talk about the uses and abuses of statistics. And I checked before I loaded them last night. I actually changed your notes pages to give you more room to write. Now, the thing to remember here is that sometimes we read a percentage and just believe what it says. We don't think about, whether it makes sense or whether it ought to be true. And then besides our own willingness to believe percentages are true, I mean, after all, somebody said it, it must be true. It was on the internet, it must be true. We're really very susceptible to believing things that may or may not be true without really considering why they might or might not be true. The other thing that happens with uses and abuses of statistics is when people deliberately mislead us. They actually are trying to fool us. So that's two different categories of errors. The first category, actually, we need to talk about something called Simpson's paradox. Now, Simpson's paradox, I'm going to tell you what it essentially says in English. Okay? It says something appears to perform better in each of two or more group comparison, but actually, overall, it's worse. It doesn't improve, it actually gets worse overall, even though in all the little subgroups of something, it seemed to get better. So we're going to look at an example to try to put some sense into this. And here's a good illustration of Simpson's paradox. We have somebody that is interested in studying acne treatments. And in this acne treatment, what they do is they're going to apply the treatment to some people and see how many got better or how many didn't get better. Get better means they're cured. Okay? There is an old treatment that they used and they had on hand, but they also have developed a new, better, and improved treatment. Now, this doesn't have to just be for acne medication. This could be for laundry detergents. You watch television, it's new and improved. This year's Chevy is bigger and better. Okay? So you hear these comparisons all the time. The question is it true? Is it true? Well, in order to make a determination, control for any possible variables, they decided that it would be best in this particular case to divide their group of sample subjects up into people that had mild acne and those that had moderate acne, because it might work better if you only have mild acne, but if you have moderate acne, it might not work as well, or vice versa. So they divided that up to control for how bad it was when you first had it. Looking only at the people that have mild acne. With the old treatment, we had 2 people that were cured and 8 that weren't. And with the new treatment, we had 30 that were cured and 60 that weren't. Now, what we want to do is we want to see whether or not that's an increase or decrease and how big an increase or decrease. So looking at the old treatment, 2 people out of a total of 10 people were cured. 2 plus 8 is 10. So 2 out of 10 or 2 over 10, that ratio is 20%. So 20% of the people with mild acne were cured using the old treatment. Makes sense so far? With the new treatment, 30 people were cured and 60 were not cured. That's a total of 90 people. And 30 out of that 90 people were cured by the new treatment. So 30 over 90 is 33.3%. Well, 20% is less than 33.3%. So it appears by these percentages that the new treatment cured more people, therefore it was effective. The new treatment is effective for those that have mild acne. So let's see about this, people that had severe acne. In the people that had severe acne, we had an old and new treatment. Under the old treatment, we had 40 people that were cured and 40 that weren't. So 40 out of the total of 80 people that took the old treatment is 50%. So the old treatment, for those that had severe acne, it did seem to be effective. It was 50%, but the new treatment is even newer and more improved and better, because 12 people were cured out of a total of 20 people. 12 plus 8 is 20 that took the new treatment. And 12 out of 20 people is 60%. So yeah, the old one seemed to work, but the new one works even better. Right? Based on what we've seen so far, is the new treatment better?
Yes.
Yes, does seem to be. Now this is where Simpson's paradox comes in. What if we don't divide up between the mild and the severe? What if we take everybody all at once and do old and new treatment? Well, if you combine everybody, there were 2 people cured that had mild and 40 people cured that had severe acne, for a total of 42 people. Out of, I think I have a typo, hang on. No, I don't. No, I don't. Because of the old treatment, we had 10 people in the mild and 80 total of 80 people in the severe, so that's 90 people. So 42 people total out of 90 people total that took the old treatment is about 46.7%. Not as wonderful as it seemed to have been in the last part, but okay, it seemed to have worked. Now we do the new treatment. Well, with the new treatment, we had 30 people that had mild plus 12 people that had severe, for a total of 42 people that were cured. But that's out of a total of 20 people plus 90 people, which is 110. 110 total people. If you add up this whole row, that's 110. And 42 out of 110 says the new treatment only cured overall 38.2%. Is the new treatment better? No. That's what Simpson's paradox says. If we looked only at mild people, they improved. If we looked only at the severe people, they improved. But if you put them all together, they didn't. The new treatment didn't help if you lump them all together. Now what we want to talk about is, why is that? Why is that counterintuitive? It made perfect sense that if you had mild acne and the new treatment percentage was higher, and if you had severe acne and the new treatment percentage was higher, well then the effective thing was the new treatment. But when we combine, it doesn't appear to be true.
Sampling error.
It is a sampling error. That's a good point. It actually comes in the guise of a sampling error. The old treatment actually worked better overall, but this is why it worked. The number of participants with mild acne was 10 with the old treatment versus 90 that took the new. But if you were one of those 10 in the old treatment, your results only counted 1%. I'm sorry, 10%. Your results counted 10%. If I'm one of 10, I have a lot louder voice than if I'm one of 90. I don't really have much to say if I'm one of 90. So if I'm one of the 90 that took the new, my results only counted right at 1%, a little better than 1%, 1 over 90. Okay? With the severe acne, you had 80 people that took the old treatment versus 20 people that took the new treatment. And one person out of this entire 80 is only about 1% each. But if you were in the new treatment group, you were 1 out of 20, so your actual contribution was 5 times as much as theirs. So you had a lot more influence on the results. Okay? But if you look at the overall participants,
Can you go back just a second?
wait, wrong way. Stop that. So really, if you think about it, what's wrong here is our sample sizes are not very close to each other for the old and the new treatment. 10 versus 90 gives the 10 way too much weight. And 80 versus 20 gives the 20 way too much weight. Okay? But if you lump them all together, 90 versus 110, 90 old treatment versus 110 with the new treatment. Okay, that's not equal, it's not perfect, but that's a lot closer to being even. In fact, 1 out of the 90 people, your voice is a little more than 1% each. Whereas if you're one of the 110 people, 1 over 110 is a little less than 1%. So right at 1% for both groups, which means that the combined group is actually going to be a far more reliable answer, even though it makes the other separate groups sound like that they're false. The results are true, but because of the way they set up the sample, it wasn't fair. I guess that's the best way to say it. The Simpson's paradox tells you when things are not fair. Now, a lot of the time, what the advertiser wants you to hear is the people with severe acne were cured at a much higher rate. People that had mild acne were cured at a much higher rate. Buy my new treatment. Their new treatment is a waste of money. The old treatment worked just as well or better. Okay? So this could actually be an example of how do people lie to you using percentages. They use Simpson's paradox. Now, it might not have been deliberate. They might have just wound up with these people divided up this way. If they took a simple random sample, it could have happened. But in order to be honest, whoever researched this treatment method should have been honest and said, okay, these are the numbers, and while we get this percentage for this group and this percentage is for this group, the truth is if we count all these people together, the new treatment is really not all that much better. Okay? Now let's look at a different example. We have here 2 basketball players, which I hope both of them are still relatively well known. We have Shaq and we have Vince. Now in this case, we don't have to calculate percentages. Okay? they've been given to us, and if they give you the percentages, say thank you very much and just go on and use those percentages. But just to make sure you see where they came from, 4 baskets out of 10 attempts is a 40% free throw. Okay? 3 baskets out of 4 attempts is a 75% free throw success rate. 1 over 4 is 25%, 7 over 10 is 70%. So looking at what percentages we're given, who had the higher completion rate in the first half? 40% definitely trumps 25%, right? So that would have been Shaq. Who had the higher completion rate in the second half? Not by much, but still 75% edges out 70%. So it's still Shaq. But then if we look at who performed better overall, was it Shaq? Well, if you look at overall, first half and second half combined, Shaq made 4 plus 3 or 7 baskets. But that was 7 baskets out of 10 plus 4 total attempts. Vince had 1 plus 7, which is 8 baskets, but his total number of attempts was also 14. So that makes Shaq's 7 over 14 a success rate of 50%. But that makes Vince's success rate 57.1% because he has 8 over 14. So who performed better overall in both halves? It was Vince. Even though Shaq, if you took it by the halves of the game, Shaq was more successful. But if you look at the overall game, Vince was the one that actually was more successful at the free throws. So again, if you use the broken down results, they don't necessarily match the overall results. Shaq's folks are going to want to use the first half and second half results separately. But the true sports analyst is going to say, no, we need to analyze the game as a whole, not just the first half and second half. Okay? Now let's talk about the other way. And these are 2 ways that people actually attempt to deceive you. And it might work if you don't really think through the process. Our first example says, because of losses by your employer, you agree to a temporary 10% pay cut. Boss comes and says, look, if you'll take a 10% decrease right now for the next 6 months, then at the end of this 6 months, when things pick up a little bit, then I'll give you a 10% pay raise after that 6 months. Now, since he's cutting you 10% now and giving you back 10% later, how does that work out for you?
10% off now, since you make more, is it gonna, it's not gonna restore the original salary.
No,
Like
you
if I
don't-
make $500 a week and they take 10% out of it, and they get $450, and then he adds
10% back, but that's only 10% of
$45.
What you're making at that
at
moment.
what you're making at that moment. Okay, so it'd be 450 times 10%, so only $45 more. So yeah, you're still coming out in the hole, okay? Now here, without having to work through every single salary possible, let's think about how we know that. Will it restore your original salary? And the answer is no. No, it will not. And if you wanna look at why that is, again, I'm gonna step outside this for a second and try to use the approach that you did. Let's suppose right now, today, I make $500 a week. Okay? If I take a 10% cut, I'm only gonna make 90% of that 500. Which is $450 a week. So then, this is the first 6 months. I'm gonna make $450 a week. Second 6 months, I'm gonna get my 10% back, maybe. So in the second 6 months, I'm going to start with my $450, and I'm gonna get an increase so that's gonna be 1.10 times 450, or logically, 10% of $450 is $45. So this is gonna actually come out to be $450 plus $45 is $495. Is that as much as I made to begin with? I'm still making less. Okay? Still making less. Now the question is, can we quantify that? And we can. We're actually talking about 3 different time periods here. First 6 months, which as we've said, you start out making 100% of whatever your salary is. We arbitrarily use $500. You could have started at any amount you wanted to. And basically, for the first 6 months, I'm gonna make only 90% of what I used to make. So I'm gonna multiply by 0.90. But in the second 6 months, I'm gonna take 100% of what I'm making at that beginning of that second 6 months, which is gonna be the result of the first 6 months. So it's not gonna be 100% of my salary at the first 6 months. It's 100% of my salary during that first 6 months, which is actually only 90% of my original. But I am gonna add 10% to it. So what that's gonna make me do, without having to go through all of the different steps, is I'm gonna start out with 100% of my salary. And in the first 6 months, I'm gonna multiply that by 0.90. And in the second 6 months, I'm gonna multiply it by 110 to get the overall, without breaking it up into groups. So overall, it looks like I decreased and then increased. I'm sorry, looking at the 2 individual time periods broken down, decreased and increased. But overall, 100 times 0.90 times 1.10 is only 99%. Check it out. Overall, whatever my original salary was, 100% of it, all of it, times 90% of it, times 1.10 or 110% of it, gives me 99%. Okay? And I've got a typo here, let me get that out, because that really isn't a decimal number, it's just 99. Because this is 100%. Okay? So I'm really only making 99% of my original salary. Now, going back to the example we started out with, we were kind of trying to do this by common sense. If I took my original salary, which was 500, and multiplied it by that 0.99, let's see what we get. $495. So the process that we looked at actually is shorter than going through all of these different arithmetic calculations over here. The easier way to do this whole problem is to take your original whole complete amount, 100% of it, and then multiply that times 0.9 for the 90%, and then again times the 1.10 for the 110%, but you come up with 99%, which is 0.99. And that's how that 500 went to 450 for 6 months, and then for the next 6 months I made $495, and at the end of that time I'm making $495, which is only 99% of my original $500. So did I actually come out in the long run? No, I still lost. Maybe not a whole lot, but you know, if I'd started out with a lot more, I might have lost a whole lot more too. Okay? That's what's called a shifting reference value. Your employer's saying, well, if you'll take a 10% cut now, I'll give you a 10% pay raise later. The problem is the reference value of 500, if you use that for both values, well, that's not the way to do it, because you don't have $500 during the second 6 months. Okay, so they shifted the reference value and hoped you didn't see it. So here's another example. Apparently my stockbroker's a really lousy stockbroker. And he's also a liar, as a matter of fact. But if I'm not smart and I don't question his word, if I say, oh, you're my stockbroker, you have this big degree in finance, you must know what you're talking about, then he can lie to me all day and I won't know any better. But I need to know how to tell if he's telling the truth. So the stockbroker offers me the following defense to the angry investors, that'd be me. I admit that the value of your investments fell 60% during my first year. But this year, their values increased by 75%. So you're really 15% ahead. Are you? Well, no. If it fell 60%, then that means I only had 40% of my investment for the first year. Even though during the second year I did increase by 75%, which is 175%, but not of my original investment, only of 40% of my original investment. Okay? So if you start out with everything I had invested and you multiply it by 40% for my 40% loss, and you multiply it by 1.75%, or 1.75 for my 75% gain, how much of my original investment do I have at the end of the second year?
70%.
Only 70% of it. I don't have 15% ahead. I'm still 30% behind. Okay? So my stockbroker not only is not a very good stockbroker, but he's a liar as well. He's just trying to cover his tracks. Okay? This is one of those that, you know, you want to believe the numbers. It sounds good, it sounds right, but if you actually analyze the numbers like a good consumer, it tells you the truth. Okay? Don't believe everything that has a number applied to it. This is another example of shifting reference values. 60% of the people in my night class are women. 80% of the women are married. Does it follow that 48% of the people in my night class are married women? Well, let's think through this. This actually, I always think a picture is worth 1,000 words. So let's take my whole night class, and out of my whole entire night class, I take 60, I'm sorry, that's supposed to say 80%. To fix that. I got my percentages crossed up, I think. So if I take 80% of my night class and pull them out separately, there's the women in my night class.
I think you had it right the first time.
Yeah, I did. Okay, my night class. 60% of the people in that night class are women. So the women's subgroup, which is represented by those ovals, the whole night class is obviously bigger than the group of women. Okay? So when I pull out the women make up 60% of my class. Now, when I say 80% of the women are married, well, that 80% is coming out of only the women, not my entire night class. Because this is only talking about married women. So does it follow then that married women only make up 48% of my night class? Let's say I started out with 100 people in my night class just to make it easy. Okay? 60% of 100 means I have 60 women in my class. 80% of those 60 women, 0.8 times 60, means that 48 of them are married women. And 48 out of my original 100 students are married women. Make sense now? It's always easy to think of it that way. Here's 100 people, 60 of those people are women, and 80% of those women, 60 times 0.8, is 48 married women. Okay? Same idea here. 70% of the school students are freshmen. 10% of the students carpool to school. Does it follow that 7% of the school's freshmen carpool? %10 of all the students carpool. That's out of all the students. So if I take 70% out of the school to find the freshman group is smaller than all the students. In fact, following the same logic I used before with an easy number, if I have 100 students, 70% of that 100 students is 70 students, okay? 70 students are freshmen, okay. Now we have this 10% that carpool. The question is, are these carpoolers coming just out of the freshmen, or are they coming from all of the students? It's coming out of all the students. Okay? So how many carpoolers do I have? If I had 100 students, 10% times 100 is 10 students. 10 students carpool. Okay? What's 10% of the freshman students? There's only 7 of those carpoolers that are freshmen. The others are not freshmen. Okay? Because it says 10% of these students, all is implied, the whole entire student body. It didn't say 10% of the freshmen. It says 10% of the students, all of the students. So it does it follow that 7% of the freshmen carpool? No. Well, actually, yes. 7% of the freshmen carpool, not 10% of all the students necessarily, but 10% of all the students if you even separate them out. 10% of the freshmen is 70%. So yeah, the answer to the last question is yes, it follows that 10% of the 70% is 7%. Now here's practice problems, and you have these problems on your handout for your notes. This is your assignment for tonight. What I have put in here is practice problem 1, 2, and 3. And what I want you to do, since it is 9:45, you have about 15 minutes. And in that 15 minutes, what I would like for you to do is to work together on those problems. And once you've done that, wait, wrong unit. Where's unit 1-4? Then you can go into Shobi. And I did modify the handouts in Shobi to make it easier for you to actually enter these in. I don't care if you do that page, or that page, or that page, or not in Shobi, but I do want you to put your answers to the last page in Shobi. Okay? Now you need to show your work, but I am going to have the answers up here so you can check your answers before you have to go. I know most of you have to leave at 10.
knows? I did not know this was anyway. Why I don't, I taste all this, and then the question, for some reason, it had both,
Get both of them?
it had both of them on this one, this one, and that one.
Even though you erased what you originally had.
Yes,
wrote on the
yes,
top of it.
yeah, yeah,
This doesn't come twice, so.
yeah, so I erased
Okay.
it, and it's still,
What I would suggest that you do is do your corrections in a different color pen.
well, it won't let us write on here, no, oh, next time.
Yeah.
Next time,
Yeah.
okay,
Yeah, next
Okay.
time, just do any corrections you make, just draw a line through what's wrong
okay,
and then make your corrections.
okay. 'cause
And
this
I'm
is-
trying to modify all of these too, to give you more room, because,
Okay.
see, I made the quiz and I gave you plenty of room to write your
Yeah.
answers.
Yeah,
And some of the handouts are kind of tight, so that's why I went ahead and changed this one, when I realized how much trouble everybody's having with them jammed up. I'm spreading them out. You may have one that'll have 15 pages and one problem on each page.
Right.
But I'd rather do that.
yeah, cause this is supposed to be like two, what are the first ones, one of them, this is supposed to be $1.99. That's supposed to be 93. I got a 93 later.
Okay.
But I don't. Cause I mean, when you hit a raise,
Okay.
it goes all the way.
But did you go look at the answers and make sure you
Everybody knows
had?
your money. Let's go up.
It will, that one should.
Because I posted the answer sheets.
Uh-huh. Yeah, that one should, and this one, the $1.99 does. I know, this one should be
I'm gonna show 10%
$200.
less.
Most of the red Roman numbers,
10% less
that should be
time.
$221.
Yeah.
Well, then I just, I just.
I think I can read it.
Okay.
If I can, I'll ask you a question.
I just wanna let you know I didn't turn that mess in my head.
Okay, I didn't know it did that.
Yeah.
Next year, it's cleaner.
That's really didn't on the other one, when I raised the seats,
30%
my opinion, everything.
Or I show up.
Right after that,
30%
phone
late.
number, it fits what
Now,
I
that
said.
might have caused a problem, but I don't think it will.
I don't know what to do.
But all this-
I have a student account that's in my class only and try that on
Check,
check.
yeah, okay.
There was an episode.
But see, I raised some of the others that were done, they didn't do that. Just on those three. I'm on the same.
What are these musicians?
Yeah, that's odd.
And then on my other iPad, when I go in there, to show you, I thought,
Very good show.
didn't even say nothing.
Talk about numbers. Numbers lie. It's-
Unless I'm just crazy with it today.
No, I don't think so. I think there's a lot of those things.
Frank
Oh, yeah.
Lewis, who's a